So, I am Cadet Malinaw and I am here to tackle about the errors associated with magnetic compass. Magnetic compass errors. The magnetic compass is the simplest instrument in the panel, but it is the subject to several errors. To consider the acronym of VD-MONA. VD-MONA stands for V is for variation, D is for deviation, M is for magnetic depth, O is for oscillation, N is for northerly turning error and it parts of magnetic depth. A stands for acceleration or deceleration errors and also part of magnetic depth. Variation. Latitude and longitude are based on true directions, means they provide a constant horizontal and vertical plane with which to reference on maps and charts. The magnetic pole to which the magnetic compass is not collocated with the geographic true North Pole, but it is some 300 miles away. Direction measured from the magnetic poles are called magnetic directions. In aerial navigation, the difference between true and magnetic directions is called variation. Same angular difference in surveying and land navigation is called declination. An isogonic line connects points on equal variation on a map. The amount of variation depends on your location relative to the poles. Variation in equatorial regions will be less dramatic as isogonic lines are farther from each other. Conversely, at extreme northern and southern regions, isogonic lines are more pronounced as lines are closer together. The agonic line, the line that passes near Des Moines, Iowa, and Little Rock, Arkansas has a variation of 0 degrees, making it the agonic line. Right of this line, the magnetic pole is to the west of the geographic pole, and a correction must be applied to a compass indication to get a true direction. Flying in the Washington DC area, for example, the variation is 10 degrees west. If the pilot wants to fly a true course of south 180 degrees, the variation must be added to this, resulting in a magnetic course to fly of 190 degrees. Left of this line, the magnetic pole is to the east of the geographic pole, and a correction must be applied to a compass indication to get a true direction. Flying in Los Angeles, California area, the variation is 14 degrees east. To fly a true course of 180 degrees, the pilot would have to subtract the variation and fly a magnetic course of 166 degrees. So subtract the 180 degrees and 14 degrees and the result is 166 degrees magnetic course. And the direction is east or west can be tricky to remember given they would otherwise be considered opposite. However, if you think of looking at the world from the pole, vice your location toward the pole, then it makes sense. The variation error does not change with the heading of the aircraft. It is the same anywhere along the isogonic line. So, isogonic lines are depicted on sectional charts with a dashed magenta line, and the number associated used to convert true course to magnetic course. So, correcting for variation, true course is 170 degrees plus negative sign variation plus 13 degrees equals magnetic course 180 degrees. The magnetic course 180 degrees is flown if there is no deviation error to be applied. So, variation memory aids. West is best, so plus sign. East is less, negative sign. Or variation east, magnetic track, less, negative sign. While variation west, magnetic track best, plus sign. Isogonic lines of variations. Deviation. Local magnetic fields in an aircraft caused by electrical current flowing in the structure in nearby wiring or magnetized part of the structure cause a compass error called deviation. Deviation manifests itself differently between aircraft and depending on heading. However, it is not affected by the geographic location. Deviation error is minimized when a pilot or aviation maintenance technician or AMT performs the maintenance task known as swinging the compass. Most airports have a compass rose, which is a series of lines marked out on a taxiway or ramp at some location where there are no magnetic interference. Lines oriented to magnetic north are painted every 30 degrees. So, um, the corrections for variations and deviations must be applied in the correct sequence, and this is shown below. Starting from the true course, desired error due to magnetic interference with metal components in the aircraft as well as magnetic field from the aircraft's electrical equipment. Compensating magnets inside the compass can help reduce this error but not eliminate it. So, and then the correcting for variations, magnetic course plus negative sign deviation equals compass course. Assume that a magnetic course of 180 degrees as above plus negative sign deviation equals negative 4 degrees. So, 180 degrees minus 174 degrees equals negative 4. Assuming from correction card equals compass course 176 degrees. Magnetic compass deviation card, pilot handbook of aeronautical knowledge, magnetic compass deviation card. Note that intermediate magnetic course between those listed on the compass card need to be interpolated. Therefore, to steer a true course of 180 degrees, the pilot would follow a compass course of 188 degrees. To find the true course, when the compass course is known, compass course plus negative deviation equals magnetic course plus negative variation equals true course. Magnetic dip, compass tends to dip toward the magnetic pole, most dominant as latitude increases. The lines of magnetic flux leave the Earth at the magnetic North Pole and enter the magnetic South Pole, pronouncing magnetic dip near the poles. At both locations, the lines are perpendicular of the Earth's surface. At the magnetic equator, which is roughly halfway between the poles, the lines are parallel with the surface. Within 300 miles of the poles, the instrument is unreliable through extreme errors. So, to counter this, the pivot point on which the bar magnet swings is deliberately placed at a position other than the magnet's turning error. Turning error. The pole of the vertical component of the Earth's magnetic field causes northerly turning error, which is apparent on a heading of north or south. When turning from a northerly heading, the compass will initially turn the opposite direction and catch up by due east or west. So this is the rules of this. The role of this error when starting a turn from a northerly heading, the compass indication lags behind the turn. The role of this error when starting a turn from a southerly heading, the compass indication leads to turn. If the turn is made from north to west, the aircraft banks to the left and the compass card will tilt down on the left side. The magnetic field pulls on the end and the magnet that causes the card to rotate toward east. So this is if the turn is made from south toward west, the magnetic pole starts the card rotating toward west again. In the same direction the turn is being made. So turning error mirror age, onus means northern hemisphere, undershoot north, overshoot south. New heading, roll out heading plus negative latitude minus half the bank angle. So this last errors, acceleration and deceleration error. The dip correction causes the end of the float card marked north, the south seeking end, to be heavier than the opposite, and when the aircraft is flying at a constant speed of heading or east or west, the float card is level. So this the acronyms ANDS stands for A stands for accelerate north, D and S stands for decelerate south. Acronym SAND SA stands for south accelerate, ND stand for north decelerate. And from the table below, as you can see, there is a apparent turn and the direction below. So next is, what are the methods of determining the errors of gyro compass? So the errors to which a gyro compass is subject are speed error, the latitude error, ballistic error deflection, ballistic damping error, quadrantal error, and gimballing error. Additional errors may be introduced by a malfunction or incorrect alignment with the center line of the vessel. Speed error is caused by the fact that a gyro compass only moves directly east or west when it is stationary on the rotating earth or placed on a vessel moving exactly east or west. Any movement to the north or south will cause the compass to trace a path which is actually a function of the speed of advance and the amount of northerly or south heading. This causes the compass to tend to settle a bit of true north. This error can be corrected internally by means of a cosine mounted on the underside of the azimuth gear, which removes most of the error. Any remaining error is minor in amount and can be disregarded. Tangent latitude error is a property only of gyros which Mercury ballistics and easterly in north latitude and easterly in south latitude. This error is also internally by offsetting the lubber's line or with a small movable way attracted to the casing. Ballistic deflection errors occurs when there is a marked change in the north-south components of the speed. A change of course or speed also result in speed error in the opposite direction. Ballistic tampering error is a temporarily oscillation introduced by changes in course or speed. During a change in course or speed, the ballistic is subjected to centrifugal and acceleration or deceleration forces. This causes a torquing of the spin axis and subsequent error in the compass reading. Slow changes do not introduce enough error to be a problem by rapid changes well. Quadrangular error has two causes. This causes the gyro to tend to swing along its heavy axis as the vessel rolls in the sea, and minimized by adding weight so that the mass is the same all direction from the center. The second source of quadrangular error is more difficult to eliminate as a vessel's rules in the sea. So, gimballing error is caused by taking readings from the compass. When it is tilted from the horizontal plane, it applies to the compass itself and to all repeaters. To minimize these errors, the outer ring of the gimbal of each repeater should be installed in alignment with the fore and aft. Of course, the lubber's line must be exactly center as well. So that's all of the topic that we tackled.